embellish your question a bit. I want our audience to enjoy this one. Okay, thank you. So imagine that you are a senior high school student in a school where there are bed bugs. So many of your mates have bites and all kinds of skin troubles. Now, knowing that you're a good science student, you have been listening to your science lessons well, you know you can help them. Biology teacher says sulfur can help. So you go to chemistry lab and you find 3 compounds. There is a silver sulfide, copper 2 sulfide, and bismuth 2 sulfide. All of these are potentials because they have the sulfur, right? Okay. Now, what you have to do is to decide. Remember, in round 1, we're talking about sustainable chemistry. So we want to use harmless materials. So we want to use water as a base to get the sulfur and then use it to treat your colleagues so that they can pay you and you make money. These people like money. They are in the money zone. So now, which of them should you use? This is what the question is about. Really, that is what it is. So the thing is, you need to determine the solubility of sulfur in an aqueous environment, right? Check to see which one will produce more sulfur in the watery environment so that it can be very effective at treating the things on the skin of your colleagues so that they will pay you. That is what this is, right? Of course, being a science student, you also have access to handbooks. So you can go and check for certain values, solubility products. And this is what was given in the problem. 3.2 times 10 to the negative 50, 1.00 times 10 to the negative 46, 1.08 times 10 to the negative 73. You can get this from a handbook. So now, before you even go to the lab and waste all kinds of chemicals, you can do some simple calculations. You see, they did it in 4 minutes. And then decide which one to go and target. Of course, if you're a high school student, make sure you involve your teachers and don't go and take the chemicals without permission. So, okay, so how do we go about this? We want to determine the solubility of the 3 salts to find out which is more soluble and produces the most ions of sulfur in an aqueous solution. You start with your balanced equation. Okay, that's the proper way of doing things. So for the silver, we have Ag2S going reversibly to 2Ag plus S2 minus. So the solubility product will be obtained by multiplying the concentration of Ag plus squared, multiplying the solubility of the sulfur. Sulfur 2 minus is an ion. That is what it is. So now from the balanced equation, okay, if we call the solubility of the sulfur S2 minus S, then we can obtain the KSP by taking, you look at the balanced equation, you have 2S multiplying S, and this 2S for sulfur plus, and then S for S2 minus. So if you look at the balanced equation, you get 2S squared multiplying S, because you see when you balance it's 2Ag plus. Okay, so 2S squared multiplying S, and this is equal to the solubility product. Okay, when we do this, then we can simply calculate for S. It's going to be the cube root of 3.2 times 10 to the power negative 50 divided by 4, the square of the 2. That's where the 4 comes from. And this will give you 2.0 times 10 raised to the power negative 17 mole per decimeter cubed. Okay, mark allocation. Balanced equation, 1 point. Calculation all the way to the correct answer. The process is worth 1 point. The final answer, 1 point. 3 points for this. Okay, then we take the second one, CUS. The balanced equation, CUS going reversibly to Cu2 plus S2 minus. Again, we call the concentration of S2 minus the solubility of sulfur S. So this time we'll have S squared is equal to the solubility product. And so we have S to be equal to square root of 1.00 times 10 to the power negative 46. And this is 1.00 times 10 to the negative 23 mole per decimeter cubed. Similar mark allocation, balanced equation 1 point, process 1 point, final answer 1 point. Then we go to bismuth. The bismuth sulfide. Bi2S3 going reversibly to 2Bi3 plus 3S2 minus. So now we have 2S and then 2S. So you have 2S squared multiplying 3S cubed. Okay, so now the solubility product is going to be 108 S to the power 5. And so S is fifth root of 1.08 times 10 to the power negative 73 over 108, and this will give you 1.00 times 10 to the power negative 50 mole per decimeter cube. But you are not done. You are not done, because if you look at the balanced equation, you remember that you have 3S. And so you need to multiply this by 3 to give you 3.00 times 10 to the power negative 15 mole per decimeter cube. Balanced equation, 1 point. Process, 1 point. Final answer, 1 point. And then finally, when you look at these values, you will see that bismuth 3 sulfide gives the highest amount of sulfur in an aqueous solution, and so that is the one you should target. Instead of just trying and wasting a whole lot of chemicals, go straight for the bismuth sulfide. For saying this, for concluding so nicely, 1 more point, giving a total of 10 points. This was how to tackle the problem of the day. Now, contestants, Adisadel College. Silver. No balanced equation in sight, but you do go through the process to get the right answer, 2 points. Copper, the copper compound. No balanced equation in sight, you have the right solubility at the end of it, 2 points. Bismuth, no balanced equation. I'm giving you 1 point for the process. You didn't get to the right final answer. But you did conclude that we should go with the bismuth. For that reason, I will add 1 more point, giving you 6 out of 10. Presbyterian boys. Silver compound, no balanced equation, right calculation of solubility, 2 points. Copper compound, yes, you have the balanced equation and you have the right calculation, 3 points there. When it got to the bismuth, no balanced equation, or you did have a balanced equation. I didn't give you anything because, in fact, you started dealing with a different compound that I didn't recognize. You had boron instead of bismuth, just B. So I didn't even recognize it. Anyway, I'm giving you 1 point for process, okay? So that gives you, and then you couldn't do the rest. I mean, the rest you didn't have the right thing. And then the conclusion, because of the nature of the compound you have there, that's not the compound we have in our problem. And so I couldn't give you the final mark. So you also wind up with 6 out of 10. Prempeh College. For the silver compound, yes. You have a balanced equation, you have the right calculation, 3 points. The copper compound, your balanced equation is not dealing with ions. You are dealing with elements. So I'm not giving you for the balanced equation. By your calculation, you get 2 points for that. I didn't see an equation for the bismuth. No, it was not a good one. But you have for the process, I'm giving you the point for the process. Final answer was not right. It wasn't. And yes, you did conclude that we should go with the bismuth compound, and so I'm giving you 1 more point. That gives you 7 out of 10.